So hope you have tried the linear equations practice question set in the article, and here I'm going to discuss those two questions, how to solve this linear type of the equation. So this type of equation is in the form dy over dx plus pxy equals qx. So this type of equation is solved by taking the integrating factor. So in the article I have provided what is the integrating factor and how to determine and the steps of doing these types of equations. So now I'll show you how to do this question. So we have x dy by dx minus 3y equals x to the power 6 and ex. So this type of equation, first we need to divide this x, divide the whole equation by this x. So we get dy by dx minus 3 over x y x to the power 5 ex. So now this is in the form that I showed you earlier, dy by dx plus pxy equals qx form. And now we can take the integrating factor. Integrating factor is e to the power px dx. So here px is 3x dx. So now I'll do this question clearly. So here we have, here is the px, so minus 3 over x is the px, and now we can take the integrating factor. Integrating factor equals e to the power minus 3 over x dx. Minus 3 over x dx, we get minus 3 ln x, and here e to the power ln x to the power minus 3, and we get the final answer as x to the power minus 3. So now the step 2 is to multiply both sides of the equation by this integrating factor. So x to the power minus 3 dy by dx minus 3 over, so when we multiply this by this, we get minus 3 over x to the power 4y equals x squared minus x squared e to the power x. So x to the power 5 into x to the power minus 3, we get 5 minus 3, 2. So now we can see this is the differentiation of 1 over x to the power 3y. We get x to the power minus 3, then dy by dx, and we get minus 3 of x to the power 4 and y. And here x squared e to the power x. And then we take the differentiation of both sides, then the integration of the both sides. So we then get x to the power minus 3y equals integral x squared ex dx. Here we have to do the partial differentiation to get the integral of x squared ex. So we can take the answer like this: x squared ex minus 2x ex dx. So here uv dash, so that method is uv, so we take u and this is as v dash, and then we write uv minus vu dash. So I'm not going to explain that method. So hope you have done that method in the integration lessons previously, or if you have not, you can master it in upcoming articles, or you can grasp it here to how to do these integrations. So here x squared ex minus 2x e to the power x dx, we get x squared ex minus 2 x ax minus ex, and here y over x cube is equal to x squared ex minus 2x ex plus 2x ex plus c. So plus c is a must because it's an arbitrary constant. So now here we can substitute, we can subject y here by multiplying this whole equation by x cube. So we can keep the answer like this. We have taken y equals explicit solution. So this method of linear equation is the big deal is to identify the integrating factor, then multiplying the whole equation and identifying what is the derivative in the left hand side, and then integrating the right hand side to get the equation like this. So moving on to the second question, we have dy by dx equals x plus y sine x over 1 plus cos x. So making it to the standard form of the linear equation, we get x over 1 plus cos x plus y sine x over 1 plus cos x. So taking this to the other side, we get taking this to the other side, so because here y is there, so dy by dx minus y sine x over 1 plus cos x equals x over 1 plus cos x. So here the identifying integrating factor, so here integrating factor is sine x over 1 plus cos x. So the integrating factor is with y, so minus sine x over 1 plus cos x dx. And here by simplifying we get ln 1 plus cos x. So we get the final answer of the integrating factor as 1 plus cos x. So multiplying the whole equation by 1 plus cos x, we get 1 plus cos x dy by dx, and so 1 plus cos x and 1 plus cos x cancel out. So here we have y sine x equals, so here also 1 plus cos x to 1 plus cos x cancel out, and here we have x. So we can see this is the integration differentiation of 1 plus cos x y, 1 plus cos x times y, and here is x. And by taking the integral of the both sides, we have y times 1 plus cos x and x dx. So here y times 1 plus cos x equals x squared plus 2 plus c, where c is an arbitrary constant. So here we can take the solution y equals 1 over 1 plus cos x times x squared over 2 plus c. So here says explicit solution of this equation. So here the main deal is, as I said earlier, we have to identify the integrating factor and then multiply both sides of the equation by the integrating factor, and identifying the left hand side as the differentiation of some function, and then taking the final answer like this. So as I summarize here, dy by dx plus pxy equals qx. This is standard form of the linear equation where the integrating factor is e to the power integral px dx. So hope you have a clear understanding of these linear equations and how to solve them. So go through the article and do the example questions, practice these practice questions, and stay tuned for more topics in the ordinary differential equations. Thank you.